Hello students and welcome to the lecture. So students, as you can see here that basically in this lecture we are going to start a discussion over the uniform circular motion and centripetal force. This is the topic that we are going to start. Uniform circular motion and centripetal force. Okay. In this lecture we will talk about introduction, inertial and non-inertial frames of reference, some illustration of centrifugal force, and at last we will see the summary of all of these. Okay, but before starting this, as usual, we have our small disclaimer that we are required to understand before we proceed further. So the disclaimer is like, the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Now let's begin with the topic. So if we take the introduction of this topic, so we could say when we call a body is in the circular motion. So when a body moves in a circle, its direction of motion at any instant is along the tangent to the circle at that instance. For example, you can say suppose if there is any body that is moving in a circle, so its direction it's always tangent to the circle at that instance, or you can say this like. Okay, from the figure we find that the direction of motion of the body moving in a circular goes on changing continuously. Like first it was in that direction, then this direction, then this, then this, then this. So you can say as the body progressively moving in a circular motion, its direction changing continuously. Okay. According to the first law of motion, a body couldn't change its direction of motion itself. Like if you remember when we were talking about the Newton's laws of motion, so there were the three laws. Out of these three, the first law of motion that we talked about, what was that? The first law of motion stated, if there is any body which is having a certain state of rest or motion, that body will not be able to change its initial state without any external help. If the body is at rest, the body will remain at rest until or unless some external force applies on it to make it move. If the body is in motion, it will remain in motion until or unless any external force applies on it to stop it. Okay, that is what we had discussed. So if we take the first instance of this, like according to the first law of motion, a body couldn't change its direction of motion itself. Okay, so this is here the first law applies, that by itself the body will not be able to change its direction of motion. It required some external force. An external force is required for this purpose, as I have told you right now. This external force is often called as the centripetal force. So centripetal force is the force that is basically helping the body to change its direction as the body is moving in this circular motion. Okay. Thus, the centripetal force is the force required to move a body uniformly in a circle. So suppose if you having any body and you want this body to be move in a uniform circular motion or uniformly in a circular motion, you require the centripetal force. Without having that centripetal force, that body will not be able to move in a circular motion uniformly. Okay. This force acts along the radius and towards the central of circle. If this is the center of the circle, suppose here is the body. So now you can say this force that you are seeing, or this line is basically the centripetal force. Okay, this is the radius and this is the center. From body to the center of circle through the radius, the centripetal force acts along. Okay. Now we have the centripetal acceleration. Acceleration acting on the object undergoing a uniform circular motion is called the centripetal acceleration. Why? Because basically the centripetal force is the force that is making the object to move in a circle uniformly. So the object which is generating the acceleration while moving, that acceleration will also be called a centripetal acceleration because of the uniform circular motion and the virtue of centripetal force behind this. Expression for centripetal acceleration is A is equal to V square by R is equal to W square by R, where V is linear velocity, W is the angular velocity, and R is the radius of the circular path. Expression for centripetal force, then F is equal to M into A is equal to M into V square by R is equal to M R W square. Okay. Now we have the centrifugal force. Suppose if we talk about the centrifugal force, suppose we are working from a frame of reference that is rotating at a constant angular velocity W with respect to an inertial frame. Okay. If we analyze the dynamic of body of mass m kept at a distance r from the axis of rotation, we have to assume that the force m into W square into r acts radially outward on the body. Like you can say, suppose if this is a person who is basically the center of the circle. This is the radius. This is the object. So basically now you can say there are two arrows. First arrow is denoting the centripetal force. The force that is inward towards the center of the circles. Okay, that is the centripetal force. Another force that you are seeing is the centrifugal force, the force that is outward towards the movement. Okay, so now when the person tries to rotate this ball in a circular motion, so basically that person making this object to go far away from the center. Okay, and this is happening by virtue of the centrifugal force. So now you can say it is radially outward on the body. Only then we can apply Newton's laws of motion in the rotating frame. Okay. This radially outward preceding force is called the centrifugal force. So the force that acts on an object which is moving in the circle and the force is radially outward, then this force will be called as the centrifugal force or the preceding force. Centrifugal force is a force that arises when a body is moving actually along a circular path by virtue of tendency of the body to regain its natural straight line path. Like if we talk about this body actually having the straight path. Okay, but right now instead of going to the straight, the body is revolving in the rotation. That is happening because of the effect of centripetal and the centrifugal force. If we talk about the centrifugal force is having the tendency of the body to regain its natural straight line path. If only the centrifugal force will apply here while rotating this object, the ball will go straight instead of going on round. Centrifugal force acts along the radius and away from the center of circle. Okay. Note that the centripetal and the centrifugal force acts always on the different bodies. Okay. Here you can say two bodies are there. Okay. So now centrifugal force is basically applying on this object and centripetal force is applying on this object. In fact, centrifugal force is a sufficient preceding force only if we are analyzing the body at rest in a uniformly rotating frame. If we analyze the motion of body that moves in a rotating frame, we may have to assume other preceding force together with the centrifugal force. Such force is also called the Coriolis force. The Coriolis force is perpendicular to the velocity of the body and also perpendicular to the axis of rotation of the frame. Once again, we emphasize that all positive forces, whether centrifugal or Coriolis, they are needed only if the working frame is rotating or in the motion. If the working frame is in the rest, we not require them that much. But if it is in a rotation phase, we require them so that we could analyze the situation and draw on our scientific conclusions. If we work from an inertial frame, there is no need to apply any residual force. Okay. Note, it is a common misconception among the beginners that centrifugal force act on a body because the body goes on a circle. Centrifugal force act or assume to act because we describe the body from a rotating frame which is non-inertial and still use Newton's law. So that's why centrifugal force is applicable there. Okay. Because there is a third law which says there is a equal and opposite force. Okay, so like if you are rotating any object in a circular path, you are applying the centripetal force towards the radius of that circle or towards the center of that circle. Okay, so if you are applying only one force and there is no equal and opposite force, what will happen? After one time, the object will come to the center and the rotation will stop. That's why we assume that there is a centrifugal force that is also applying while moving in a rotation, and this force is having the tendency of equal and opposite in respect to the centripetal force. Now we have the inertial and non-inertial frames of reference. A reference in which Newton's law hold is called an inertial reference frame. In such a frame, the net external force on a body is zero. The acceleration of body will also be zero. Okay. A reference frame which is at rest or is moving with a uniform velocity is an inertial frame. An accelerated frame is called a non-inertial frame. Okay. Like rest or uniform velocity, inertial. Accelerated or non-uniform velocity, non-inertial frame. Remember this difference. In order to make Newton's law applicable in such a frame, we introduce a fictitious force which is supposed to be acting on the body so that the Newton's law of equal and opposite reaction could be applied here. The magnitude of this force is equal to the product of the mass of the body and acceleration of the reference frame, and its direction is opposite to the acceleration of the frame. Okay, like here you can say if you are try to move any object here, this is your pushing force, the force that you are applying. This is a force of action, which means equal and opposite force. Similar happening there. Such a force is called an inertial force or residual force. Example of residual force is the centrifugal force. Okay, like whenever there is a object that is moving in a circular path, basically the centripetal force is being applied on the object and also the centrifugal force applied on the object. Now some illustration of centrifugal force. The concept of centrifugal force has wide applications. Following are a few of such applications which illustrate the utility of centrifugal force. First is the centrifuge. Centrifuge is actually a device used to separate the lighter particles in suspension from the more dense liquid in which they are contained. Like you can say, if you look at this, you will find that there is a beaker in which there is a liquid. Okay, this liquid may contain some lighter particles and another dense liquid is there. In order to separate it, we use the centrifuge. Okay, we rotate it so that the lighter particles comes up and the dense liquid goes down. This separation will take place. Such a mixture is poured into the container or tube of the centrifuge, which is then whirled at high speed in a horizontal circle. The lighter particle move towards the axis of rotation. When the centrifuge stops, the suspension is the container is found at the top and the clear liquid at the bottom. follows that the heavy particles in a suspension will collect at bottom of the container of the centrifuge, leaving clear liquid at the top. On this principle, if we talk about cream is separated from the milk, cream separators. Sugar industry, sugar crystals separated from the molasses. Wet clothes dried by the dry cleaners in the drying machine. Centrifuges used to separate honey from the wax. Ultracentrifuge used to separate finest particles of the sediment from water or from even highly viscous liquids. Another application of centrifugal force is the centrifugal pump. By making use of centrifugal force, it is possible to transfer the large quantities of liquid against low back pressure. Such a device is called the centrifugal pump. This pump also used as exhaust fans and blowers. After this, we have the centrifugal governors. By making use of centrifugal force, the speed of an engine could be automatically controlled. Such an automatic device which could control the speed of engine, we called it as a speed governor. Here we have finished the topic, not part for the summary discussion. We have talked about when a body moves in a circle, direction of motion always tangent to the circle, continuously changing due to an external force called the centripetal force, acts towards the center of the circle. Centripetal acceleration we have talked about. Centripetal force we have talked about. In a rotating frame of reference, preceding force that is presented called centrifugal force we talk about. This force is necessarily applied to apply the Newton's law in non-inertial frame. Okay. Another preceding force, the Coriolis force, acts perpendicular to the velocity and axis of a rotating frame. These preceding forces not intended in an inertial frame where Newton's law directly applies. Centrifugal force often misunderstood as acting on a body moving in a circle, but actually due to the describing the motion from a rotating frame. Inertial frame is one where Newton's law holds without preceding forces, while a non-inertial frame requires the introduction of such forces. Application of centrifugal force we have talked about, including the centrifuge, centrifugal pump, centrifugal governors. With this, we have finished this lecture. It is requested to all of you kindly revise the facts and figures at all we have discussed in this lecture and keep yourself ready for the next lecture. With this note, let's end this lecture and thank you.